All right, I'm on page 15 of the review packet, and I'm going to be reviewing graphing quadratics. So, the first thing that I notice, I'm looking at number 40. I see this squared term. What that tells me is I'm going to have a quadratic function. And I know that if I have an x squared, if I have a quadratic function, then that means it's going to be a parabola. So quadratic functions, when you see the x squared, you think parabola. But in this case, I have a negative number outside my parabola. That means it's going to be facing downwards. And because it's a 2, I have a 2 there, it's going to be a little bit steeper than my regular parabola. So it's going to be kind of steep. And if we wanted to graph this more accurately, what could we do? An XY table. Good. Okay. So this is my K value out here, and this is my H value in here. Remember, H we always think of as the opposite. So K, that means we're going down 4. So 1, 2, 3, 4. And then with this minus 4 in the center, it's actually plus 4. So we're going 4 to the right. 1, 2, 3, 4. There's my point. And you can estimate these parabolas. I'm fine with you estimating them. If you wanted it to be more specific, you can do an XY table. I'm confident that you guys can do an XY table for those. If you want extra practice, then go ahead and practice that. All right. Now, this is called vertex form. I'm a big fan of vertex form because it's easy for me to do the vertex. I just look at my K value, that tells me up or down, and I look inside with my H value, and that tells me if I go to the left or the right. Here in number 42, we don't have that. This is called standard form. But you guys know how to calculate the vertex for standard form. The formula is negative b over 2a. You plug that back into your formula to get k. So we know that. So let's calculate this. Negative 4 over 2 times 2 gives me negative 4 over 4, which gives me negative 1. So now I'm going to take this negative 1. So this is equal to negative 1. And I want to solve for k now, so I'm plugging this back in to my x. So 2 times negative 1 squared plus 4 times negative 1 minus 1. Oh my gosh. My voice is, my nose, sorry. Okay, negative 1 squared gives me a positive 1, because negative 1 times negative 1, positive 1. So 2 times a positive 1, 4 times negative 1, negative 4 minus 1. Well, I know this is 2 minus 4 minus 1. Okay, 2 minus 4 gives me a negative 2. Negative 2 minus 1 gives me a negative 3. So I have negative 1 comma negative 3. I'm going to plot that. Negative 1, 1, 2, 3. Now my a value is a 2 here. The coefficient of x squared is 2. That's positive. So that means, and it's 2, not 1. So it's going to be a little bit steeper than normal. Here's my estimation. Now, if I wanted to get specific of where my points hit the x-axis, I know my x-intercepts are the same as the roots. And for roots of a quadratic, I can use a quadratic formula. Let's see how accurate my graph was. I'm going to do the quadratic formula. So negative 4 plus or minus the square root of 4 squared minus 4 times 2 times 1 all over 2 times 2. All right, so negative 4 plus or minus the square root. Negative 4 times 2 gives me a negative 8. Negative 8 times negative 1 gives me a positive 8. So here I have a positive 8, and this is going to be 16 plus 8 over 4. Negative 4 plus or minus. So 16 plus 8 is going to give me 24. Oh man, I was hoping it would come out nicely because square root of 24 isn't a perfect square root. However, we could reduce it, right? So if I'm reducing the square root of 24, this would break off into let's just say the square root of 4, square root of 6. Square root of 4 is 2, and square root of 6 is square root of 3, square root of 2, but those don't reduce. So 2 square root of 6 was what I would reduce to. I could plug this into a calculator and get my 2 roots, but I'm not going to do that. I'm just going to assume that I'm somewhat accurate. I could also do an XY table. I'm going to leave it at that.